Hello, everybody, and welcome to part 6 of Senior Developer in 24 Hours. Today, we're going to be talking about automating the build of our application. All right, so what does automating the build mean? It basically means having all or most of the steps of the build process handled by a system as opposed to a person doing it manually. And the idea here is that we're hiding the complexity of the build process to make it easier to develop. And because we're hiding all of the steps, because we're making things automatic, it ensures that the process is reproducible if we do things right. Okay, keep in mind that automating the build process has two main purposes. The first one is to make it easier for your peer developers to build the component and to be able to keep developing. And the second one is normally to have it invoked by your CI system. And there is a lot of overlap between making it easier for your peer developers and making it easier for your continuous integration system to automate things. But for now, we're going to focus on automating this to make sure that it is easy to use for our peer developers, for our teammates. We'll focus on the CI/CD part in a future session. So let's keep that in mind as we move forward, that we're focusing on developer productivity. Because developer productivity is the main reason why we are going to be doing this. The truth is that developer productivity is paramount in any organization. The time of your teammates and also your own time is most likely the most valuable resource in your organization. And removing toil respects that time. And just for the definition here, toil is basically any operation that has to be done manually over and over again and provides no enduring value. And building your application, if you have to do it manually, it doesn't really provide you any enduring value. But if we spend the time to automate it, that is going to provide enduring value, because then other people are going to be able to leverage what you have built, and they're going to be able to reproduce it a lot quicker. And keep in mind that automating the build is a tiny part of an emerging practice, which is called developer productivity engineering, which is using metrics, using best practices to ensure that we are making it easier for our developers to be as productive as possible. Okay, so what does the build tool that we're going to use to automate this build actually do? Normally, it will fetch and manage dependencies for us. It will actually build the code. It will ensure that the right options are used to build the code. It will also package the code into a way in which it can be consumed by other teams, by QA, by our users, in a way in which we can deploy it into the different environments in which it's going to run. Automating the build normally also entails running the test. And finally, it can generate a few reports that we can then use to gather metrics and make informed decisions of where should we be spending our time. Okay, so what tools are we going to be using? And your choices depend a lot on the language that you're using. And there are a lot of different tools that we can choose from. And again, up to a big part, the choices that you have depend on the language that you are using. For example, if we are using interpreted languages that do not require actually building an application, normally we focus more on dependency management tools that will help us manage our libraries. And for example, if we're talking about Python, then we would be using pip. If we're using Node and the Node ecosystem, we would be using npm, the Node package management. On the other hand, if we are using compiled languages, for example, C, C Sharp, Java, etc., the choices tend to be very ecosystem specific. For example, if you're on the JVM, Maven and Gradle tend to be the options that most people um, use. If you are on the .NET environment, MSBuild, which is the main tool for the environment, or some other alternative tools that are tailored directly to the .NET environment are popular, for example, Cake. And then finally, if we have a very varied ecosystem, if we have different languages, we can use some of the tools that are more generic. Make, which is the quintessential build tool, and the Swiss Army knife that will allow us to do pretty much anything, is very popular. And now there are tools that are more comprehensive, that provide a lot more functionality. For example, Bazel, that allows us to automate the build of very large code bases that have different languages, that have, a lot of different variety. Um, at the end of the day, the objective of our build is to have some artifacts that we can publish. So we should ask ourselves, in the process of automating our build, what are the artifacts that we are going to want to share? For example, it could be libraries, it could be binaries, it could be completely built installation artifacts, it could be documentation, it could be API specifications. Who should have access to these artifacts? Who is the intended audience, and how can we package our artifacts so that they're useful for this particular audience? And where are we going to store them? So some of the artifacts that we're going to be producing so that they can be published are things like, again, binaries, container images, deployment descriptors, libraries, documentation, testing results, code quality results. There are a lot of different artifacts that are going to be the outputs of this build process. Because any build process has a set of inputs, which is normally your source code, a set of processes, which are defining whatever build files you're creating, and then a set of outputs, which are the artifacts that eventually will be able to publish so that other entities can consume them. If we want to dig a little bit deeper into automating the build, we're talking about a series of steps, which I've broken down here in 7 different steps. First, defining the component metadata, managing the toolchain, managing the dependencies, compiling the code, running the tests, running any extra checks, and finally, publishing the artifacts that we built throughout this process. Okay, so let's start from the beginning with component metadata. And component metadata is basically the basic stuff that we need to get out of the way. But if we are automating our build, we have to come up with some sensible values for naming your component. And I know that, naming things tends to be pretty complicated. It is a big decision, but it is a decision that we have to make, and we have to make it in a sensible way so that our users will be able to consume it based on the name that we're creating. Depending on which ecosystem we're living, there might also be a group name. Group name tends to be sometimes a fully qualified domain name. So that one might be, just come from our organization. It is very likely that it has already been defined. And then finally, the version of the component that we're building. We're going to go into a little bit more detail about versions in just a second. But also, other things that are nice to have. For example, description of the component, links to documentation, things like that. These are the basic pieces of information that we have to define as we're starting to automate the build. All right, now let's talk about versions. We want to use a sensible versioning scheme. And there's two main versioning schemes that are fairly well accepted. One is the semantic versioning, and the other one is calendar versioning. So let's take a quick look at each one of those. Okay, semantic versioning is normally defined as a version that has a major, minor, and patch component to the version. Major, if you bump the major version, it means that you introduce incompatible API changes. So a user of a previous version, if they try to upgrade to a new major version, they might run into incompatibility issues that they'll have to deal with. If we increase the minor version, we're adding functionality, but it is done in a backward compatible manner. So again, if they're upgrading and they're upgrading to a new minor version, they should be able to get new functionality, but without breaking the code that was already relying on this particular piece of code. And finally, the last component is the patch. The patch indicates that it is a bug fix and it is done in a backward compatible manner. So again, it can be updated without any significant issues. Okay, things to keep in mind. If you're going to use something that looks like Semver, semantic versioning, make sure it behaves like semantic versioning. Also, keep in mind that marketing can be a concern when you're defining your version numbers. The truth is that version 2.0 sounds a lot more exciting than version 1.1. So marketing might have a say on this for things that are external facing. So, keep that in mind. All right. Also keep in mind that if your software is being used in production, if you have users that depend on your API, and if you're at the point where you're actually worrying about backward compatibility, then your library, your piece of software, whatever you're building, should be at least 1.0. So, don't be afraid to reach that milestone where you say, hey, this code is already being used. Let's bump it all the way to 1.0. All right. With that said, let's talk about calendar versioning. Okay. So calendar versioning is a scheme that is a little bit more freeform. We have a major segment, and normally it is the one that is most commonly based on a calendar. Then we have a minor version and a micro version. And the minor and the micro might be calendar elements or they might not be. And also you might have an optional text tag, which is a modifier. And the best way to understand calendar versioning is to look at some examples. So, for example, Ubuntu. You have Ubuntu version 22.04 LTS. So this is a version that was released in 2022 on the month of April. So this one has a major and a minor version. And it also has a text modifier, which is LTS, which means long-term support. So here we're using, again, major, minor, and modifier. If we look at YouTube DL, which is a very popular library, they use something like 2021.05.16. The first segment is the year, the second segment is the month, the third segment is the day in which this particular version was released. Very easy for a user to determine, hey, is the version that I'm running very old? Should I be upgrading? Very intuitive. IntelliJ IDEA uses versions that look like this, 2023.1.1. The major segment, which is 2023, is the year in which the version was released. Dot one and dot one, the minor and the micro versions, they are just incrementally increased. So they're basically counters. But again, if you take a quick look at this, you can tell, hey, am I running this year's version of IntelliJ? Am I running last year's version? So again, very intuitive. And when you're choosing a versioning scheme, keep in mind, how do your users consume your application? If it is a consumer application, then calendar versioning might make a little bit more sense because it makes it very intuitive for the users to, hey, I'm running something that's outdated. I'm running something that is still pretty recent. Do your users care about what changed? Do they care about how significant the changes are, or do they only care if they have the latest version to make sure that it is secure, make sure that they got the bug fixes that they want? Do your users care when they need to upgrade? If they really care about when to upgrade, again, because they want to get the security fixes, because they want to get whatever new features, whatever new improvements, then calendar versioning might be a little bit more intuitive. If they care more about what has changed, how significant those changes are, then semantic versioning might make a little bit more sense. We also want to keep in mind how often are we releasing. For example, are we releasing every week? Are we releasing every year? Those things should be taken into account when we are figuring out what versioning scheme we want to use. We also want to keep in mind how consistently are we releasing. Hey, is it again every month or whenever we have something new to release, etc. But the important thing is to keep in mind that versioning is an important part of your artifact. It is important in the sense that it is supposed to convey a lot of information for your users. So you want to make something that works for your users and it works for your team. And you can read more about the two versioning schemes that I mentioned today if you go to the respective websites. Very easy, semver.org or calber.org. So if you're interested in this topic, feel free to read more. They go into a lot more detail than what I did today, but at least we have a basic idea of what's out there and what we can leverage to come up with a reasonable versioning scheme. All right, now let's move to the second step, which is defining our toolchain. Okay, so the toolchain are basically the tools that we rely on to automate the process. So we're talking about the build tool itself, any preprocessors that might be involved in the process, compilers and linkers, require runtimes. For example, if we need a special runtime to execute the application to run our test, something like an application server, things like that. All of these things are part of the toolchain that enable us to take the code that we've written and build it into the artifacts that we were talking about before. All right, so the most important thing about the toolchain from the perspective here is, how do we make it available to your developers? How do we ensure that the toolchain is consistent? And there are a couple of ways, well, more than a couple of ways in which we can do those things. So the most basic one is have your developers install things manually on their laptop. It works. In this case, well, documentation is critical to make sure that your developers are successful in installing things manually. It is workable, but it's very manual. If you have a lot of developers, it can be very problematic. If you work in a large organization, you can leverage the infrastructure your IT department has to pre-install the tools on the computers, on the laptops that your team are going to be using. So requires a little bit of coordination with people outside of your department, but you can definitely leverage the resources of your organization to make this work. We can also use a wrapper to download part of the toolchain. We're going to go into a little bit more detail about this one soon. And finally, we can use containers. Right now, we're trying to use containers for pretty much everything. So why not use containers to distribute our toolchain to our developers? And we're going to go into a lot more detail in just a second about that one also. All right, but let's begin with the wrappers. Wrappers are very popular in the JVM ecosystem, particularly for Maven and Gradle. The wrapper requires that the right Java virtual machine already be installed in the computer, but other than that, it takes a lot of the guesswork of having stuff installed. Wrappers work very similarly. Basically, you commit a very small executable, an executable jar, to source control. Normally, we recommend never commit any executables, never commit any binaries to source control. But for wrappers, we make a tiny exception for this very small executable. And the idea is that this very small executable will download the build tool. It will download, the exact version that is configured in our source code. Once we have downloaded that specific version of the build tool, the wrapper will execute the build tool. And then the build tool will do all of the magic, downloading all of the other dependencies, running the executable, and so on. Okay. The last option that I'm going to go into detail is dev containers. And again, like I mentioned, we're trying to do everything with containers now, from running our CIs to deploying our applications. Hey, why don't we use the same technology to define our toolchain? Defining our toolchain as a set of containers. And this in particular is a open source technology that has been developed by Microsoft. It is open source. And it works by defining the containers that you're going to need in a file called devcontainers.json inside of your source repository. And with this, we can let the IDE know which containers we need, how those containers need to be built, and then the IDE can leverage those containers to use the tool chain that is installed inside of the container. Dev containers require Docker to be installed, but it is just one piece that then can be used for lots of different projects. You can use this to be able to maintain projects that have incompatible tool chains, that have very outdated tool chains that you normally don't want to have installed in your laptop. You can package all of these things into containers. All right, so now let's take a look at how dev containers work in an actual demo. All right, let's take a look at how a project with dev containers looks like. We have a file called dev containers inside of a folder called .devcontainer, and it's basically a JSON file that is going to tell us the name of the container environment that we're going to be using. It also has a pointer to the Docker image that we're going to be invoking. We can also point this to a Docker file in case we want to have a custom image. Then there are some features that are going to be installed inside of the container. In this case, because this is a Java project, I am installing some Java features. In particularly, this is installing Gradle, but it can also install things like Maven. Then there are some customizations that can be applied to VS Code itself. We also have a list of ports that are going to be forwarded from our local computer into the container. And then we can also specify commands that are going to get executed after the container is fully initialized. In this particular case, I'm just displaying the Java version, but it's nothing. But you can add more complicated stuff here. All right, given that we have this file and we have Docker running, we have the dep containers extension installing Visual Studio Code, I can reopen my project inside of the container. Okay, so now we see that the Gradle project is getting imported inside of the container. We can also open up a new terminal, and this terminal is running inside of the container. So if I do Java version, what I'm going to see here is the Java version that is installed inside of the container. This is different from the Java version that I have in my local computer. Same thing with Gradle. I have a version of Gradle installed, which should match 8.1.1, which is the same version that I specified that I wanted to have installed in my container environment. Now with this set, we have a fully built container that VS Code can deploy its remote extensions to, and we can, for example, we can even go and execute our code inside of this container using the Gradle version and the Java version that we have defined inside of the container. And this is a very basic Spring Boot application, and it has a single controller, and it's listening on port 8080. And with this, we can check and see how we can hit the application from our local computer into the container. Because we're forwarding port 8080, we have the application running inside of the container using the Java version that comes bundled with the image that we're using. It is also built with the Gradle installation that we deployed. So this is an easy way for us to define a development environment that developers can quickly bring up. As long as they have Docker, they'll get the full toolchain that we have specified, and they can be up and running with very little headache. Right, so in this video, we started taking a look at some of the steps that we need to automate our build. We went into detail about some of the topics like versioning, how to distribute the toolchain, things like that. We're going to continue on the same topic in the next video. We're going to go into a lot of detail about how to manage dependencies. We're also going to talk about some of the basics of ensuring that you're compiling your code in a way that is reproducible. We're going to introduce the concept of automating the testing, automating quality checks on your code, and polishing the artifacts. With that said, thank you for watching. Hopefully you will join us for the next video. Don't forget to subscribe, and you can follow me on Twitter, you can follow me on Mastodon, and you can also check out my webpage, www.javaprocess.com. Thank you.